Tuesday afternoon. Optimization. Also, the last thing we look at before the second exam. So an optimization problem or an applied optimization problem involves maximizing or minimizing a specific value. To find the maximum product of two numbers having a sum of 100. So represent the two numbers by x and y. We're looking for the maximum of the product. Call it P. X times y. It's a problem. That function is two variables. We have a constraint. The sum has to be 100. If that's the case, y would have to be 100 minus x. There's our product function. Find the maximum. We actually also need a domain.
I suppose all real numbers. One could be a large negative number, the other could be a large positive.
In this case, it is all real numbers. Right, there's no restriction. Since the domain's all real numbers, I'm not even bother writing it. I don't worry about it if we're restricting the domain. To find maximum, what did we have to do?
Well, that's an extrema, so we need critical points.
How do you find critical points?
You see where that is either undefined, which in this case there is no.
Where what is undefined?
No, wait, no, not that function. We need the derivative of that function.
What is that derivative?
The 100 minus 2x.
Is that undefined anymore?
No.
So it's defined everywhere. Where else would critical points be?
Where that function is equal to 0.
We get x to be 50. How do you determine if that is a maximum or a minimum?
You test values to the left and right and take the sign.
Could. There's another way. Hmm? Plug it back in where? That's just going to give us what the value is. It doesn't tell us it's a max or a minimum. So you could set up the test interval if that works. It also requires a bit more work. There was a second method. It was introduced last time but not used. The second derivative test. Optimization, I typically use the second derivative test.
What that only do with the relative max?
The corollary is if it's the only critical point in the interval, it is an absolute. So in this case, it will give us an absolute, because there's only one critical point. What is the second derivative? Evaluated at the critical point 50. That was less than 0. Which means it does result in a max. Bless you. Then what's the maximum product? How'd you get it? Minimum sum of two positive numbers whose product is 500. again, just define your two numbers as x and y. We're trying to find the minimum value of x plus y, let's call that s. Given a constraint, actually we're given two constraints. Product is 500 and both numbers have to be positive. R would then have to be 500 over x. There's our sum function. X plus 500 over x. Domain, we're told that x has to be larger than 0. There's no other restriction on x, though. X could theoretically be as large as we want it to be. Take its derivative. Anywhere that's undefined,
Well, no, it's really 500, that would be 500, 501, that would equal 0. So, and we're gonna need that later, though.
is there anywhere this is undefined?
0, it's undefined as 0.
Do we have to worry about that? So it's defined everywhere. Because 0 is not in our domain. Now just set it equal to 0 and solve. Solving for 0. We're solving x squared minus 500 equals 0 for x. Two solutions. Right? Plus minus root 500. No, but x has to be greater than 0. So you get 10 root 5. What's your second derivative? second derivative, then, at 10 root 5, what kind of value do we get? We don't care what the value is. We just care positive or negative, or 0. So second derivative test tells us what? If the second derivative is positive, then that point results in what kind of extrema? And what's more, because we only have one critical point in our interval, it's an absolute minimum. So what is the minimum sum? Let's get it. Why is it being multiplied by 2? But how do you know that y is also 10 root 5? You just plug x in, and you will get y to be 10 root 5. X simplified. Maximum sum.
Hold on. Just did this, and we only found one critical point. And then that was the min.
So what does that mean for this?
It means I don't know what to do from here.
Does there?
Well, I mean,
Can you think of a function that has a minimum but no maximum? I can.
so there can be a horizontal axis. Like it approaches something, but never quite reaches there.
It doesn't have to be horizontal.
That's even worse.
X squared has a min but no max. So just because a function has a min doesn't mean there has to be a max. so close. You're so close. You have to put it all together.
So, you want me to say the third black I'm putting instead? Or should something put to get in there?
You're right, there's only one critical point, which resulted in a min. So what does that mean about this problem?
Well, the only things to consider are the range limit tonight. And if it's not zero, is the maximum sum infinity, is just.
The maximum just be 20 times.
That's the minimum.
If you want one of those to say there is no maximum.
There's no max. The work just shows that the critical point results in min. So, yeah, something like this could appear on an exam. When you do all that work only to realize there's no solution. In other words, the sum is increasing without bounds. Right. Because I can make x as large as I want. It would just mean that y becomes really small, right? The larger x becomes, the smaller y becomes. If x is 500, y has to be 1. If x is 1,000, y has to be a half. Right? If x is 1,000,000, y is just 500 over 1,000,000. And notice what's happening to the sum. The sum is increasing without bound. Maximal area of a right triangle whose hypotenuse is 1. So just as with related rates, first step is to label values and picture. Bless you. Here's our right triangle with hypotenuse 1.
And if it's a right triangle, the other two sides are equal to each other. So could we get away with defining them under one variable?
Do they have to be equal?
Yeah. Oh, no. They just need the right angle. Sorry, I thought I was going somewhere there. Equal out?
Yeah, an equilateral triangle is one where all the sides are equal. But that, by definition, can't be a right triangle.
Sorry, I just need connection down.
I'm just going to call them B and H for base and height. What is the function that we want to maximize? which is what?
1/2 base times height.
Which in this case, base and height are just base and height because it's a right triangle.
And our constraint would be that b squared plus h squared has to equal 1.
Very good. This is an implicit constraint. Solve for 1. Either B or H. Which one do you want to solve for? It doesn't matter. What does B have to equal? Like that? You sure?
I think that's what we do.
You sure? I'm going to take that as a no because now you're questioning yourself. Why? Well, if you're going with algebra, that'd be plus or minus.
Can't be simplified, final answer, lock it in.
No, that's right. I'm asking why. Right. So why is it not plus or minus? I don't see area. Why can't it be negative? Again, what does area have to do with this? This is just base.
It's a length. And we don't,
It's a length,
we
and
don't
length
have
can't be
direction.
negative. Length is a positive measure. What we've now done is written area strictly as a function of h. What is the domain? What was it?
Zero to positive infinity, not including 0.
So you're saying just greater than 0?
Just greater than 0, yeah.
0 to 1.
0 to 1, why?
Because b squared plus h squared equals 1. So it can't be greater than 1.
Why not?
Because then that other line would be 0. So it would be a triangle. But if h were to be 1, then it would be b squared plus 1 equals 1. And that b would be 0. Which can't be 1.
Okay, so I agree it can't be 1. Why can't it be larger than 1?
Is that a constraint?
Why?
Because then you have to line.
You could also just look at it's a right triangle, which means that hypotenuse has to be the longest length. Which means h has to be less than 1, otherwise it wouldn't be a right triangle. H, Derivative of A. I'm too lazy to do it by hand. This requires product rule. And chain rule. And you calculus derivative with respect to H. There you are. I think they have this simplified command. They don't, but I can do functions, right? Is there anywhere that is undefined? Are they in our domain? The places where this is undefined are not even in our domain. It's undefined with an infinite number of places, by the way. -1 and smaller would give you a negative under the radical. 0 or negative under the radical. 1 or larger would give you also 0 or negative under the radical. But none of those points are in our domain. So just set it equal to 0 and solve. So what's H?
H is the square root of 1/2.
Second derivative test. Second derivative. function was. Oh, I have to do this in terms of x because I wasn't really looking for that to change the variable. So the second derivative at a critical point is less than 0. So what does that tell us?
Oh, but this is on that then.
Then what's the maximal area? Well, we know what the height is. What's the base?
Square root of 2.
Can't be square root of 2. It's larger than 1. Base also has to be less than 1. How'd you get root 2?
Try plugging in my head, I guess I'm just
Plug what in?
plug whatever is square root
In where?
of
What do you mean the original?
the original A H.
This here?
To the bottom, down the left, you get A equals A H equals.
Oh, I see what you're doing.
Yeah.
That would give you the area, which you could do. Could plug 1 over root 2 in for h in the area formula. B is also 1 over root 2.
I knew they were the same thing.
Which makes the maximum area 1/4. Ranch has 1,000 feet of fencing in which to construct adjacent, equally sized rectangular pens. What dimensions should these pens have to maximize the area? There's our two adjacent, equally sized rectangular pens. Hmm?
I think I have the constraint. No, I don't.
They'd be adjacent as well. I may have just forgotten to write the two. It is supposed to be two.
Okay, so the pens are touching.
That's what adjacent means, yeah.
So I think we should define X and Y as the length of one segment going horizontal and vertical respectively. Like for example, X could be just the length of, say, that top segment going horizontally, because that's also the length of the bottom segment. And then we just account for that in our formula.
Yeah, so we have to label, right? And of course, there's nothing saying that it has to be that. It could also be this.
Yeah. But either way, we're going to have.
Right, but it's irrelevant.
Well, either way, we're going to have 2 of one and 3 of the other. And the total length should be 1,000 feet. So that would be 2x plus 3y. That would be our constraint, right? 2x plus 3y equals 1,000.
First, what are you trying to find the maximum of?
That's the maximum of the area.
That would work, but you have to do one additional step at the end.
So that would be
So 1/2 x times y times 2.
Not times two.
Added to it. That was just one. Because each pen needs to be.
It's asking for the dimension of each pen, which is why we're trying to maximize. If you could try to maximize at the end is whatever value for x you get, you have to divide by 2. Which we're going to wind up having to do here anyway. But this is technically what we want to do, so that's what we'll stick with. Right, and this works because we're told that the areas have to be equal. Which is why we know it's x over 2. And you said the constraint was what?
The way I have it written down, 2x plus 3y has to equal 1,000.
Now, do you want to solve for x or y?
Let's solve for y since it's all alone in the area formula.
area would then be 1000x minus 2x squared all over 6.
Yes, it would.
What's the domain?
Between 0 and 1,000, because we only have 1,000 we can work with, right?
So if x is 1000, 2 times
Well, not
1000 is 2000. Which means y would then have to be negative to get to the 1000 in the constraint. Can y be negative?
no.
So that won't work.
X less than 500,
How'd you get 500?
because it's 2x, so 1,000 divided by 2.
Smallest y can be is 0. Actually, it can't really be 0. But the lower bound for y is 0, which means the upper bound for x would have to be half a thousand. It can't equal 500, right? Because then you would no longer have pens, you'd have a line.
And we're going to go for two canvas.
Depends on what the line looks like. If it's a sharp razor blade, that might be pretty good.
What these goats do to you?
Might even save some money, they won't be feeding.
Yeah, you won't be feeding either, you'll have no.
Well, I mean, if I slice them in half, I don't know.
Yeah, you eat for like a week. You eat goats to make a living. Yeah, fencing is so last decade. I think that would be more effective.
Fencing is like, yeah, but imagine all the, imagine the thieving deterrent it would cause.
But we need a derivative, right?
Do we?
Yes. Yes, I say we do.
What is its derivative? I don't even know this slide on me.
Uh, 500 minus 2x. I got that by very easy.
How did you get 500 minus 2x?
Well, I figured if you use a derivative calculator, I could do the same.
I checked to see what you typed in.
Oh, that's a problem. Well, that's very different. Okay, 1,000 minus 4x all over 6.
Which can be simplified. The 500 minus 2x over 3. Is that undefined anywhere?
No.
Set equals 0 and solve. What's x? What is the second derivative?
-2/3.
Second derivative being so what are the dimensions of each pen?
So you want the X and Y length?
So dimensions.
So the X and Y length, I'm going to assume that is, so X is still 250. And I plugged that into our formula for Y from earlier, and I got 500 over 3. That's not a very pleasing number.
I agree with the 500 over 3. I agree with the 500 over 3, although you're missing units.
Oh, well, yeah, it's both in feet.
I do not agree with the 250. 125. The 250 would be the entire length. You want each pen, so that X has to be divided by 2.
Got it.
Dimensions are 125 feet by 500 thirds. Which in reality is not going to be possible.
You can get close.
You can get close, but you're not going to get exactly that. Right, so again, the toughest part is just getting the formula. Right, finding the quantity that you want to maximize. The rest of the work should be fairly straightforward. Just like with related rates. It was that setup that was the hardest part. Solving the problem wasn't difficult. Yeah, the question is, I don't think I have time to finish this problem if I start it. So I think I'm just going to say that feels like a good place. I don't want to start and then stop. I won't even be halfway through. I think there's 2 questions left. Yeah, so we'll finish those up on Thursday. All right, don't forget you have several things coming up, and the second exam is Monday.